Let's consider how we can find velocity, accelerations, displacements when acceleration is not constant. So previously, when we had our velocity time graph, our graph looked like this. We had a nice straight line, constant gradient, and therefore we derived the Suvat equations. But what if that's not the case? What if our graph looks something like this? Perhaps a quadratic, something like that. Then we need to use the skills that we know from pure maths in order to help us solve this problem. So, let's say that we're given velocity. If we want to find the displacement, then we recall that that is the area between the curve and the x-axis. From pure maths, we know that we can integrate to find area beneath a curve. So if we integrate velocity with respect to time, we will get the area between some limits. Let's call it t1 and t0. That will come with all of the associated problems of when we dip below the axis, we'll get negative displacements. And so if we're looking for distances, we'll need to take that into account. Distance will become the kind of equivalent of raw area, rather than having positive areas and negative areas. We'll meet some of those problems when we work through problems later on. But for now, we know we can find area under a graph by integrating velocity. Similarly, if we want to know the acceleration at any time, we will need to find the gradient of the tangent at that point. How do we find a gradient? Well, again, we can recall from pure maths that if we differentiate with respect to time, that will give us the gradient, and therefore the derivative of velocity with respect to time will equal acceleration. Okay? So, using pure maths, area, integration gives us displacement, gradient, derivative of velocity gives us acceleration. Remember that that works both ways. So how I like to represent this is I have velocity, acceleration, and displacement. If I have the displacement and I want velocity, that is displacement's rate of change. So that will be differentiate. Remember, gradient, rate of change, they're the same word. Effectively, they have the same meaning in this case. If I want to know the rate of change of velocity, again, look at the derivative of that. Remembering the fundamental theorem of calculus, integration is the opposite of differentiation. If I want to travel the other way, if I integrate acceleration with respect to time, I will get velocity. Similarly, if I integrate velocity with respect to time, I will get the displacement. Remembering these, and importantly remembering them in the context of the sketches, we can solve many more complex problems.